Welcome to this lesson on further trigonometry with calculus. Today we will look at two ideas. First, finding the general solution of a trigonometric equation. Second, writing an expression as a single wave called harmonic form. Here is an important idea in plain words first. A trigonometric equation usually has more than one solution. This full set of solutions is called the general solution. It is written using a whole number called n because the pattern repeats forever. Let us start with a worked example. We will find the general solution of the equation sine of x equals 1/2. First, we find the basic solution using inverse sine. Inverse sine of 1/2 is 30 degrees, so one solution is x equals 30 degrees. Sine is also positive in the second quadrant, so there is a second basic solution. That solution is x equals 180 degrees minus 30 degrees. This gives x equals 150 degrees. Now we write the general solution in words first. Add any whole number of full terms since sine repeats every 360 degrees. In symbols, this is x equals 30 degrees plus 360 degrees times n, or x equals 150 degrees plus 360 degrees times n. Here, n can be any whole number, including 0, positive numbers, or negative numbers. Now for the check step, let n equal 1 in the first family. This gives x equals 30 degrees plus 360 degrees, which is 390 degrees. Sine of 390 degrees equals sine of 30 degrees, which is 1/2. This matches our original equation, so the general solution is confirmed. Now let us move to the second idea, harmonic form. In plain words, harmonic form rewrites a sine wave plus a cosine wave as one single wave. That single wave has a new size, called r, and a shift, called alpha. In symbols, this is written as a sine x plus b cosine x equals r sine of the quantity x plus alpha. Let us find r using a formula in words first. R is the square root of a squared plus b squared. This comes from treating a and b like two sides of a right-angled triangle. Let us find alpha using a formula in words first. Alpha is the angle whose tangent equals b divided by a. In symbols, this is alpha equals inverse tangent of b divided by a. Now let us apply this to a worked example. We will convert 3 sine x plus 4 cosine x into harmonic form. Here, a equals 3 and b equals 4. First we calculate r equals the square root of 3 squared plus 4 squared. That is the square root of 9 plus 16, which is the square root of 25, so r equals 5. Next, we calculate alpha. Alpha equals inverse tangent of 4 divided by 3. Working this out gives alpha is approximately 53.13 degrees. Now we write the final harmonic form. 3 sine x plus 4 cosine x equals approximately 5 sine of the quantity x plus 53.13 degrees. Now for the check step. Let us substitute x equals 0 degrees into both forms. In the original form, 3 sine of 0 plus 4 cosine of 0 equals 0 plus 4, which is 4. In the harmonic form, 5 sine of 53.13 degrees equals approximately 5 times 0.8, which is 4. Both forms give the same number, 4, so the harmonic form is confirmed correct. Since this topic involves a wave shape, let us look at it two ways. First, in 2 dimensions, we see the familiar sine wave rising and falling smoothly along the x-axis. Now in 3 dimensions, we can picture this same wave wrapped around a rotating circle, like a spring viewed from the side. As the circle turns, its height traces out exactly the same sine wave we saw in 2 dimensions. This shows that the single wave, r sine of x plus alpha, is really just one flat slice of a smooth rotating motion in 3 dimensions.